Hey, what's up, Logic fans? Welcome to our second video on 4.7. This is video 4.7b. Let's pick up where we left off. I want to make a point about these two rules that allow you to switch between the quantifiers. Notice that in these cases, we've just got a pretty small thing that the quantifier is ranging over here, pretty small construction. In these constructions, it's a little bit more, and I want to make sure that you understand how this is supposed to be applied correctly. So, let's go ahead and try switching these to the opposing quantifier, okay? And for example, maybe I would start. Let's start with this one actually. Let's do it like this. So if you wanted to switch this statement to in terms of the existential quantifier, what would it look like? Pause now. Okay, hopefully you're able to get it, but in this particular case, what you're going to do is you're going to go ahead and you're going to take this and you're going to move it inside. But what's inside this time is this whole thing. So it's going to end up looking like this. It doesn't just attach to the F. It attaches to the entire conditional, everything that's inside, the entire conjunction, the entire conjunction, the entire, disjunction, or if and only if. Whatever the quantifier is ranging over, it attaches. The not attaches to that whole thing, okay? So that's basically how this is going to work, all right? And then, of course, you still have to switch this to the opposing quantifier. So this would be the correct solution to this. This would not be a correct solution. This would be incorrect. This would be wrong. And this would be wrong as well, okay? So that's wrong. That's wrong. That's wrong. Okay, what I want you to do is think of everything that comes inside of this is in parentheses. Then you're moving the negation in, and it should just be ranging over the whole thing like that. Okay, so that's what it should look like, and that's important because if you use impla on this and then De Morgan's, right, it's gonna change what it ultimately looks like. Okay, so with that, go ahead and try this one. I'm going to add this negation here. If I have this negation here in B, what would the switch to the universal quantifier result in? Pause now. Okay, so what we're going to do is we're going to take it inside. We're going to switch the quantifier, and the inside this time is this whole thing. Okay? So it would look like that, all right? Now, this is an interesting case here. Let's go ahead and try, let me revise this slightly for you. So go ahead and try C now. What would that look like if we were to move or switch from the existential quantifier to the universal? Pause now. Okay, so in this case, all right, what we're doing is we're taking this one and we're moving it outside. So it's going to go outside. We're going to switch quantifiers, and it just ends up looking like that, okay? And you can, of course, get rid of these, and that's exactly what it would look like, all right? Okay, so that's exactly how that happens. Now, let me give you one last one here, just for the sake of argument. Can you go ahead and put this statement in terms of the existential quantifier? So one thing you can do here, all right, is you can change this or to an and like this, right? And this is, you're sort of picturing in your mind's eye De Morgan's. And it ends up looking like that. And now you've got a negation on the inside that you can move to the outside. So it would end up like this. And of course we have to switch the quantifier. And it would go like that, okay? And if you want, you can get rid of these guys in here just to clean it up. And that's what it would look like, okay, in terms of the existential quantifier. Let's go ahead and try another one. Let's try this one. Let's do. Let's see, how do I want it to look? Let's make it look like. What would this one look like in terms of the existential quantifier? Pause now. Okay, so this one, there's different ways you can imagine this. But one way you can imagine it is you can imagine it with two negations out here. Okay, and then you're going to take this one and you're going to move it to the inside. So let's do it that way, all right? So we're going to take this guy, we're going to move it inside, and it's going to range over the whole thing, right? And of course, we're going to have to add our existential quantifier there, and so it would result in this expression. Okay, that's what it would look like in terms of the existential quantifier. Let's go back to the original. Okay, we had it like this. An alternative way, instead of imagining the two double negations out here, you could imagine them out here ranging over the whole thing, right? And so then what we're going to do is we're going to take this one and we're going to move it to the outside. So that guy's going to the outside here, and of course we're switching quantifiers when we do that, and it results in the same expression. Okay, so that's how you handle those types of cases, and I wanted to make that point. Even though these rules are sort of stated in terms of just a small thing here, if you have a more complex construction, the knot ranges over the whole thing. All right. Okay, so knowing that you can transfer between these, right, in the way we've just practiced, let's do a little bit of multiple choice here. So just so you're really feeling like you understand the relationship between them, you know, here's two sentences. Here's a sentence I pulled out of a hat. Here's an independent sentence I pulled independently out of a hat at random. Okay, slap them both down. There they are. Now, which of these applies to this pair of sentences? So can both be true on a domain, or is it the case that both cannot be true on any domain? So there's no domain on which they're both true. Are they both true but only on the empty domain, or are they both true on all of the same domains? So they take the same truth value on every domain is the idea there. So let's go ahead and go through this. Pause now and try this pair of sentences. Okay, so you know, both can be true on the same domain. So consider it. So suppose f of x is, you know, the property constant for being red. All right, now both can be true on some domain. So imagine a domain with 3 red balls and nothing else, okay, and it's true that everything is red, and it's also true that at least one thing is red on that domain. So both can be true on some domains, right? Okay, there's all kinds of domains we can define that way. So B doesn't apply, and this clearly doesn't apply, right? And this does not apply either. Both true on the same domain. So imagine a domain that's got 1 red thing and 10 purple things, right? Then this is true, something is red, and this is false. So they don't have to have the same truth value on a particular domain. Okay, let's try another one. Suppose I picked, I don't know, this pair of sentences out of a hat, just like this, okay? So I've got this one and then this one. Which of these apply to this pair of sentences? All right, this says everything is red, and this says nothing is red. So it's kind of an interesting situation, all right? But remember, you can think about both of these in terms of, you know, the opposing quantifier. So you could think of this one as this way, right? It's like this pair of sentences as an example, all right? So it's one way to think about it, all right? But anyways, let's go through this. So can both be true on a domain? And yeah, both can be true, but only on the empty domain, right? On every other domain, they're going to contradict one another, all right? So they can both be true on the empty domain. So on the empty domain, it's vacuously true that everything is red, and it's also true that nothing is red. So that's the situation there. All right, what about this situation? What if I pulled this pair of sentences out of a hat? Which of these apply? Pause now. Okay, so let's think about this. And it really pays here to be able to switch to the opposing quantifier. So let's put them both in terms of the universal. If I put them both in terms of the universal, I get this. Now notice these are both of the form P and not P. So they cannot be true on some domains, not both of them together, and this would apply. Both cannot be true on any domain because P and not P, right? Not even the empty domain, okay? So B would be the correct answer there. All right, let's try the last one. What would it look like? It would look like this. Go ahead and try this pair. Which of these applies to this pair of sentences? Okay, once again, okay, switching to make them both in terms of one of the quantifiers. All right, if I switch this one, it would end up looking like this. And so we actually see it's the same sentence twice, in which case D applies, right? Because everything's logically equivalent to itself, okay? And if they're logically equivalent, D is going to apply. So, yeah, it's kind of a nice little heuristic device being able to recognize this formal relationship between the two quantifiers and how the negation works to handle that. Okay, so there is that basic relationship between the two quantifiers that we just explored. There's another formal relationship sort of between the quantifiers. It's in many ways the same one, okay? But it's often depicted in terms of what's known famously as the square of opposition, okay? And you can go ahead and Google this, as you can most of our concepts, and there's going to be an awful lot of history about this. So I want to introduce the square of opposition today. So the square of opposition basically consists of 4 categorical statements or sentences. I'll put it in terms of sentences, okay? And the 4 categorical sentences are known as the A sentence, the E sentence, the I sentence, and the O sentence, okay? So there's, I'm going to show you what those are in a second. And then the point is that, so this is a fundamental type of sentence or a categorical sentence, as we're going to call it. So is this one, so is this one, and so is this one. And there are interesting logical relationships between these two, okay? So let's go ahead and explore that a little bit. First of all, the categorical A statement, okay, is basically all F's are G's is how it's going to be expressed. So let's go ahead and type it. It is typically written this way, and it's broadly logically possible that it gets presented in a slightly different way. Let me go ahead and point it out here. So it looks like this, okay? And sentences of this form, right, which you're used to seeing now from our previous videos, basically say that everything in the domain satisfies this conditional description. So sentences like all koalas are cute, right? You know, let's say something like all philosophers are wise. All right, these are all examples of categorical A statements. All categorical A statements have this form, okay? And that's the basic idea. What's really interesting here is that, as you now know, the A statement is typically depicted in terms of the universal quantifier, but can also be depicted in terms of the existential quantifier. So, how would you depict the categorical A sentence in terms of the existential quantifier? Pause now. Okay, so as you undoubtedly know already, right, you could picture the categorical A statement as having the negations here. Then you're taking this one and moving it in, right? So let's take this one and move it inside. So it's going to move inside and it's going to range over the entire inside, right? And it's going to end up looking like that, okay? And then, of course, we have to switch our quantifier so that it looks like this, okay? And so the categorical A statement can be sort of put in terms of either quantifier like so, okay? Now what's interesting is that you can clean this up a little bit. So if I were to impla in here, right, again, something we'll talk about later, it would look like this. And then if I De Morganed that, right, it would end up being like this, okay? And then, of course, I can clean that up using double negation to end up with something like this. Okay, so these are equivalent ways of expressing the categorical A sentence. Okay, in the interest of time, I don't want to rush this treatment, so we'll introduce the E, I, and O on video 3, so we'll see you on 4.7C.